Okay, so Dr. Rudolph keeps talking about Sclerotinia, and as we talked about Sclerotinia in the other tunnel, when we talk about Sclerotinia, that's the genus name of a fungus. So Sclerotinia, again, causes timber rot in tomato, white rot in beans, drop in lettuce. So a lot of Sclerotinia diseases, so drop would be the name of the disease, timber rot would be the name of the disease. Sclerotinia is the name of the pathogen. So we're looking a lot at Sclerotinia diseases and working with Sclerotinia because Sclerotinia is a soil-borne pathogen, meaning it lives its entire life in the soil or at least on plants right at soil level. I said earlier, Sclerotinia does not like heat. That is why we're doing the solarization trial. So we're trying to get temperatures very high to the point not just to send the Sclerotinia into a dormant or latent period, but to actually kill it. So as she said, as Dr. Rudolph said, we have buried Sclerotinia sclerotia. Sclerotia are the survival structure. Those are the little black BB looking things. They look like rat droppings. So that is what the survival structure is of Sclerotinia. And so sclerotia can live many years or survive many years in soil even without a host. So sclerotia are a major concern. When they are 2 inches or less from the surface, they can germinate. When they're deeper than that, they won't germinate, but they can survive for extended periods. So that's why this experiment, we're looking at 2, 4, and 6 inch depths, and we're looking at those temperatures. So what we know from the literature, previously reported, previous scientists have documented that Sclerotinia will die right about that 104 degrees Fahrenheit. But that's old literature. We don't know a lot about it. And we particularly don't know what those parameters are in the soil and in Kentucky. How hot can we get it in Kentucky? So when we did the April solarization, I walked in here at it was late April, and it was 130 degrees Fahrenheit in this tunnel. So I didn't stay very long. However, those soil temperatures didn't necessarily get that high. And that's why we have these data loggers buried at different depths. So we were aiming for about 70% soil moisture. I'll let Dr. Rudolph talk more about that. And all the ends are sealed. So we're sealing in that heat and we're sealing in that moisture. So that's part of this experiment. If you were a grower solarizing your tunnel, you would not have little blocks like this. You would solarize the entire tunnel. But of course, this is research. So the Sclerotinia data that we have so far from April, we know we reached the temperatures we wanted. So we reached anything above 40 degrees Celsius at that early May, late April period. We wanted at least 4 hours of that temperature. So that's what we're aiming for. We're trying to figure out when we can get enough heat buildup to actually kill Sclerotinia. And from a research standpoint, we're aiming for that 6 inch depth, right? Because even if we kill it at that shallow depth, once you would till, it would bring it back to the surface. So it wouldn't give a complete kill. So that's what we're aiming for. So we buried Sclerotinia in some little packets of a window screen-like material. We buried 25 sclerotia per packet. And as you see behind me, all of these colored flags are not just data loggers, but also those little packets. We flag them so we can find them again. Then we bring them back to the lab, wash them off, and we plate them out to see if they're viable. So viable means, will they germinate? Will they start producing that mycelia and colonize that culture plate? And so that's what we're looking at. We're looking at viability, but we're really excited that some of them have just turned to mush. So we've already started pulling up our July trial. We have a September trial as well. So we're going to look at this 4-week total just the same, and we are burying those sclerotia. So that's what's happening in this Sclerotinia trial. And we're going to have all of this data for you at the Fruit and Vegetable Conference in January. So we're really excited about these results. We really didn't expect such exciting results. We've got a field solarization trial going on too. We're going to take a look at that if the monsoon doesn't return. But anyway, that's what's happening. We'll be revising our publication as necessary. We'll be updating grower recommendations. And also we'll be having that data for you again in January. But and also, Dr. Rudolph, the reason she might not have mentioned, the reason we chose April, July, and September, because that's typically when a grower is between seasons or between crops. So I'll let her expand on that. But as growers will cycle through crops within their tunnel, those would be the most likely times that a grower would actually solarize. So April, maybe not what I would have chosen in terms of heat buildup, but that's when a grower would do it. And that's why we chose those times. Do you have anything else to add?
Yeah, so that's a good point. You brought that up. So yeah, we chose those times based off of what we thought a grower would want to potentially work into their schedule. And I think based off the fact that we didn't get those temperatures in early April means that we probably wouldn't get those temperatures in February or March, right? So for growers out there who are wondering about, oh, could I solarize in the winter? I'm definitely not using my tunnel in December through February. I think based off what we're seeing from April's temperatures, the answer is no, not for the purposes anyway of managing sclerotinia. So Dr. Gauthier mentioned the 70% field capacity. So we irrigated this tunnel to 70% field capacity. That is from previous literature indicating that that is optimum amount of soil moisture in order to address your sclerotinia issue, right? So you don't want it to be totally dry in here. You do want some moisture. So for those of you at home who perhaps the wheels are already turning as to, okay, I want to try this. What do I do, right? You need about 70% soil moisture. So that means for those of you who don't have a way to measure that, I would say pretty wet. It won't be complete mud, but it will be wet. And so then that's a pretty good rain or a way to look at it as far as hitting your moisture levels. As Dr. Gauthier indicated, you really need to seal it off. If it is not sealed well, you want to trap that air in there, seal off the air. And so you can see wherever it is not sealed, there are weeds. And so keep that in mind. So we bury this plastic, we put sod staples at different points, and then we cover it with more soil to really trap it in. And so if you don't do that properly, you will see weeds growing under the plastic, which is obviously not what you want. And we did see a little bit of that in April, right? We were still learning and fine-tuning our skills. I think we really nailed it for July. But as you can see, anywhere where there's not plastic, there's some weeds growing, and the weeds really don't mind these high temperatures.